Hi everyone, I'm Basant Lakshan and this is the presentation of Wireless Network Technology Assignment 2. Let's see what is OSI model. OSI stands for Open System Interconnection and this is a conceptual framework for how applications communicate over a network. There are 7 layers within the model and the layers are used to help users to identify what is happening within a networking system. The OSI layers are described as application, presentation, session, transport, network, data link, and physical. These layers are provided by a mixture of network card drivers, operating systems, applications, and networking hardware that facilitate the transmission of signals over Ethernet, fiber optics, Wi-Fi, or other wireless protocols. I will discuss the layers from the top. Application layer. This is the layer that most users interact with and will recognize. The application layer provides network services to the end user. These services are protocols that work with the data the client is using. One of these protocols may be HTTP, that is used with the web browsers such as Google Chrome, Firefox, or Internet Explorer. Other examples of applications that use this layer are Outlook, Skype, Office. All of those interactive applications provide a set of services that allow the application layer to supply data and receive data from the presentation layer. The presentation layer performs the task of syntax processing or converting the data from one format to another. For an example, say you are making a payment. These transactions are typically handled in a secure transmission, which means that the data passing between the payment gateway or the website application will transmit the encrypted data to the presentation layer that will need to be decrypted or proceed. When the presentation layer processes the data from one format to another, the information is then passed to the session layer or the application layer depending on whether the data is transmitting or receiving. At the session layer, the construction, direction, and conclusion of the connections between devices occur. This layer supports multiple types of connection as well as being responsible for authentication and reconnection if a network interruption should occur. After the session is established, the data then passes to or form to the transport layer. The transport layer is responsible for the transmission of data across network connections. This layer coordinates how much data to send, how fast, where it goes, and these sort of things. Of the most widely known protocols for the internet application, these services may be provided by the Transmission Control Protocol or TCP or User Diagram Protocol UDP. Other protocols may provide additional capabilities including error recovery, data flow, and retransmission. Once the transport layer has completed its function, the data in then pass to the network layer. The network layer handles the routing of data. After the data arrives at this layer, each frame of data is examined or concluded if the data has reached its ultimate target. The layer sends data to the correct destination on outgoing transmissions and receives incoming transmissions as well. The IP portion of TCP/IP is commonly known network layer for the internet. This layer also manages the mapping between logical addresses and physical addresses for the IP addresses. This is accomplished through Address Resolution Protocol, which means ARP. The data is then passed to the next required layer, which is the data link layer. The data link layer is considered as the most complex layer of the 7 or OSI layers. This layer is often divided into sublayers called media access control, the MAC, and the logical link control, the LLC. The layer setups links across the physical network. When this layer received data from the physical layer, it checks for the transmission errors and then packages the bits into data frames. From there, this layer manages the physical addressing methods of the MAC or LLC layers. An example of the MAC layer includes 802.11, which means the wireless network. At the data link, the data passes to the final layer in the OSI model, which means the physical layer. The physical layer is the electrical physical layer of this model. This layer holds the network cables, power plugs, cable pinouts, wireless radio frequencies, connectors, transceivers, repeaters, paths of light, electric voltages, etc. When troubleshoot problems, this is typically the first place to start. At this layer, the model transmits the digital data bits from the source or sending device's physical layer over network communication media, which can be electrical, mechanical, or radio to the receiving or destination device's physical layer. Let's talk about the data and signals. Data usually refers the raw data or unprocessed data. It is the basic form of data that hasn't been analyzed or processed in any manner. Once the data is analyzed, it is considered as information. For data to be transferred electronically, it must be first converted into electromagnetic signals. The signals can be then be used to transfer data from one device to another device. The signal can be either analog or digital in nature. Let's get to know some words that we are using learning when learning signals. Peak amplitude. Peak amplitude is the difference between midpoint of the signal and the positive peak. It can be the negative peak also, but it should be a distance. Period refers the amount of time in seconds a signal needs to complete one cycle. Wavelength. Wavelength is distance between corresponding points of two consecutive waves, and the pace is measure of the relative position in time of two signals within a single period. And the frequency is the inverse of the time period. Basically, we say it as frequency equals 1 divided by the time. Here are some difference between time domain and frequency domain. Since I don't have time to explain everything, you can pause the video and go through it. There are three main characteristics which a signal depends on. First one is attenuation. When a signal simply or composite travels through a medium, it loses some of its energy in overcoming the resistance of the medium. That is why a wiring wire carrying electric signals gets warm, if, if not hot, after a while. Some of the electrical energy in the signal is converted to heat. Then the attenuation happens, and it's lost the energy of the signal. Distortion. Distortion can occur in a composite signal made of different frequencies. Each signal component has its own propagation speed through a medium and therefore its own delay in arrival at the destination. Differences in delay may create a different phase if the delay is not the same as the period duration. As you can see in the picture, at the receiver's end, the composite signal was distorted. Noise. There are several types of noise, such as thermal noise, induced noise, crosstalk, and impulse noise. may corrupt the signal. Thermal noise is the random motion of electrons in a wire which creates an extra signal not originally sent by the transmitter. Induced noise comes from sources such as motors and applicants. These devices act as sending antenna and the transmission medium act as the receiving antenna. Crosstalk is the effect of the one wire on the other. One wire acts as the sending antenna and the other as the receiving antenna. Impulse noise is a spike that comes from power lines, lightning, and so on. Bandwidth of a signal. Simply, a bandwidth of a signal is the difference between the upper and the lower frequencies of a signal. For an example, if we take two, con- two composite signals, uh, one is 1000 hertz and the other one is 5000 hertz, and its bandwidth is 4000 hertz. We can show the maximum bitrate of a noiseless channel from the formula bitrate equal to 2 into bandwidth into log 2L, and the maximum bitrate of a noise channel is equal to bandwidth into log 2 to the power 1 plus SNR. SNR means the noise level of the signal. Let's talk about signals. A signal is an electrical or electromagnetic current that is used for carrying data from one device or a network to another. There are two main types of signals, which is analog signal and digital signal. An analog signal is any continuous signal for which the time varying feature of the signal is representation of some other time varying quantity. This signal can have infinite number of values in a range. For an example, human voice in the air, video, radio transmission waves, and TV transmission waves. When it comes to a digital signal use discrete or discontinuous values. By contrast, non-digital, which means or analog signals, system use a continuous range of values to represent information. Although digital signals representation are discrete, the information represented can be either discrete, such as numbers or letters, or continuous, such as sounds, images, and other measurements of continuous system. To convert these analog signals into digital signals, we use pulse code modulation. Pulse code modulation is a modulation method used to convert analog information into digital form. The conversion of an analog signal into digital signal is based on three main principles: sampling, quantizing, and encoding. Let's talk about these three. The first step in pulse code modulation is sampling. The analog signal is sampled in every interval or a time period. The inverse of the sampling interval is called the sampling rate or sampling frequency. There are three sampling methods: ideal, natural, and flat top AS. In ideal sampling, pulses from the analog signals are sampled in the ideal sampling method and cannot be easily implemented. In natural, sampling is very speed switch in is turned on for only the small period when the sampling occurs. The result is sequence of samples that retell the shape of the analog signal. The most common sampling method called sample and hold, however, creates flat top sampling by using a circuit. The sampling process is sometimes referred to as pulse amplitude modulation. Quantization is a process of assigning a discrete value from a range of possible values to each sample obtained. The number of possible values will depend on the number of bits used to represent each sample. Quantization can be achieved by either rounding the signal or up or down to the nearest available value. The process results in stepped waveform reassembling the source signal. The difference between the sample and the value assigned to it is known as quantization noise or the quantization error. Quantization noise can be reduced by increasing the number of quantization intervals. Because of the difference between the input signal amplitude and the quantization interval decrease as the number of quantization interval increase. This would be this would be however increase the PCM bandwidth. Encoding is a process of representing the sample values as binary number in a range 0 to n. The value of n is chosen as a power of 2 depending on the accuracy acquired. Increasing n reduces the step size between adjacent quantization levels and hence reduce the quantization noise. The downside of this is that the amount of digital data required to represent the analog signal increase. Amplitude shift keying is a form of amplitude modulation that represents digital data as variation in the amplitude of a carrier wave. In an amplitude shift keying system, the binary symbol 1 is represented by transmitting a fixed amplitude carrier wave and the fixed frequency for a bit duration for a time period. If the sign value is 1, then the carrier signal will be transmitted. Otherwise, a signal value of 0 will be transmitted. Frequency shift gain is defined as the charging or improving the frequency characteristics of an input binary signal according to the carrier signal. Amplitude variation is one of the major drawbacks in amplitude shift keying. Due to this amplitude shift key modulation technique used in few applications only, and its spectrum power efficiency also low, it lead to wastage of power. So overcome these drawbacks, frequency shift keying is preferred. Frequency shift keying is also known by a binary frequency shift keying. Oh, this can be binary. Short for phase shift keying is a modulation technique used by modems in which different phases angles in the carrier signal are used to represent by binary status of 0 and 1. The digital signal is broken up according to time into binary digital and the state 0 or 1 of each bit is determined according to the state of the bit that proceed in, proceeded it. If the phase of the bit does not change, then the state of the signal stays the same. If the phase of the signal changes by 180 degrees, then the signal state change from 0 to 1 or 1 to 0. Coordinate amplitude modulation is a name of a family of digital modulation methods and related family of analog modulation methods widely used in modern telecommunication to transmit information. And thank you for watching.